For years, there's really only been one option when it comes to cooling your RV: the traditional 120-volt air conditioner. But the times, they are a-changin', and some new technology is finally here. OutEquipPro very kindly sent over one of their 12-volt roof-mounted air conditioners for us to test. So today, we're going to compare the cooling capabilities, energy draw, noise, and ease of installation between your traditional 120-volt air conditioner and these new 12-volt air conditioners. And just for transparency's sake, OutEquipPro did send me this air conditioner for free, but they are not paying me to make this video. So what's the main difference between this new air conditioner and what you may have on your roof right now? You see, it all comes down to the type of power that they use. If you've been around the channel for a while, you've probably heard me say that in RVs we have two types of electricity: AC and DC. DC power comes from your batteries and comes in right around 12 volts. AC power usually comes from plugging your RV into a pedestal, but it could also come from a generator or an inverter if you're boondocking. An inverter is just a fancy box that transforms DC power that's much easier to store into AC power that's beefy enough to run the air conditioner. Traditional air conditioners run off of AC power. This means in order to run your air conditioner, you would either need to be plugged in, running a generator, or have an inverter and a pretty significant solar setup. If you want a boondock, being plugged in is off the table. That's the whole point of boondocking. Generators, on the other hand, are super loud and not a very efficient way to create energy. Gas usage on generators really varies from unit to unit, how old it is, all that good stuff. But as a very rough estimate, if you are running an air conditioner in your RV, you can roughly estimate that your generator is probably going to use up about ½ a gallon of gas per hour to keep that air conditioner running. So if gas is sitting around $4 a gallon right now, you're looking at paying about $2 for every hour that you're running your air conditioner, which when you compare that to the roughly 24 cents an hour it would cost you to run this air conditioner if you were just plugged into your house, that's a huge difference and can really add up over time. Victron, who makes some of the most high-end inverters for RVs on the market, boast a max 93% efficiency for their inverters, which means even at its best performance, you are still losing 7% of the power that you put through this thing just in the conversion process from transforming that power from DC to AC. And that efficiency can go down really quickly depending on what brand of inverter you have and what environment you're using it in. Which has led some people to ask, what if you had an air conditioner that didn't have to run off of AC electricity and instead could eliminate the need for an expensive inverter and can just run straight off of the batteries? Enter in this new market of 12-volt air conditioners like the one made by OutEquipPro. These guys run off of 12-volt electricity straight off of the batteries without any need for an inverter, which means no needing to plug into a pedestal, run a generator, or use an inverter. And supposedly, these guys use less watts than a traditional air conditioner does, meaning that even if you aren't accounting for the inefficiencies of an inverter, you should still be able to run a 12-volt air conditioner longer than a traditional air conditioner off of the same battery bank, which is super cool. And even for those of you not interested in boondocking, this air conditioner is claiming to pull less watts, run quieter, be lighter, and supply the same, if not better, cooling than you would get with that old kind of air conditioner that's currently sitting on your roof. I'm very intrigued by this, so let's put this bad boy on my roof and see how she works. Okay, so some disclaimers about this install right at the top. This air conditioner was originally designed to be put into a van build or a Class B RV. So you're gonna have to do a handful of modifications to the installation process just to get it to work in a traditional RV if that's the route you're going. None of these mods were particularly difficult, but they did take some thinking, and it's just something you should know about before you jump into this project. Also, the OutEquipPro 12-volt AC is is designed for non-ducted AC systems. So RVs where you only use the dump vent on your air conditioner and you don't have a whole bunch of vents per se that the air gets pushed through. If you have a ducted system and find that you just don't use the vents all that often and you really only use the dump feature, then you can just tape up the holes for the ducting and just use your AC as a non-ducted AC, if that makes sense. But with all of that out of the way, here's how I installed this guy on my RV. Once I got my old unit out of the way, getting this new unit on was actually super easy. I gave my roof a little cleaning and then attached this square-shaped gasket around the hole, and then just placed my new air conditioner on top of the gasket. The fact that this AC only weighs 43 pounds makes this install so much easier. It's really hard to overstate how amazing that is. Traditional air conditioners weigh about 80 pounds, so twice as much as this air conditioner. And I'm telling you, when you're trying to get something on the roof, that weight makes a huge difference. I have done so many air conditioner installs because I'm based in Las Vegas, and getting the air conditioner on the roof is usually the hardest part of the install. And it's just much easier to get a 40-pound thing on a roof than an 80-pound thing. And the fact that the profile of the OutEquipPro's air conditioner is much lower profile meant that even with my tiny T-Rex arms, I could very easily pick this whole thing up and move it around by myself, while that really isn't an option with most traditional air conditioners. They're just so big and boxy that I can't get my arms around them. Also, about that gasket, in some of OutEquipPro's instructions, they mention caulking around this gasket before you put the air conditioner on. I think this might be more necessary on vans where they can have divots in the roof and you just want to make sure that you have this watertight seal. I never want to say 100% when it comes to RVs, but almost all of the air conditioners coming off of the line from the manufacturer do not have caulking around a similar gasket that they have. And just compressing that gasket down to the right size gives you enough waterproofing that water can't get in. But once I was down on the roof, I then came inside and attached the loading brackets. Here is where the install diverges from what OutEquipPro's instructions are going to show. The ceiling in a traditional RV is just going to be much thicker than in most van builds. And so pretty much all of the hardware that comes with the OutEquipPro's air conditioner is just going to be too short for most traditional RV applications. OutEquipPro did send 2 lengths of rod for this loading bracket, and even the longest one was too short. So I just used the shorter rods and then a coupler and then a bolt that I got at Lowe's. And that was a pretty easy way to get the length that I needed. And then I just tightened those bolts down until that gasket on the roof was compressed to about 6 to 7 millimeters. From there, you're gonna find that the screws that are meant to screw in the faceplate are also most likely going to be too short. I just went to Lowe's and got a length of 632 all thread and used that instead. In the future, I'll obviously cut these down and get some cuter hardware, but this was at least a proof of concept. Before you tighten those screws down, you're going to need to plug in the control panel on the faceplate. This is super easy. There's like 3 wire harnesses and they're each different, so there's no way that you can screw up which one is supposed to plug in where. Ooh, I'm getting like a glare. Let's change this lighting. Now, this next step may not be necessary for everyone, but when I went to install my faceplate, I found that it had like an 1/8 of an inch gap all the way around. These brackets that the AC comes with are just deeper than the lip of the faceplate. I think in a van build, these would actually get recessed into the ceiling a little bit more so you wouldn't have that interaction, but I was definitely struggling with this initially in my RV. I have thought of 2 different solutions for how you could go about fixing this, and I've come up with a 3rd solution that does not work that I'll let you know about so you don't go down that road yourself. Solution 1 would just be to grind out a little notch here and here, just where that faceplate interacts, just so it can seed in a little bit and get rid of about that 1/8 of an inch gap. Or solution 2, do what the Cummings camper did and just build a cute wooden frame to go around the whole thing to act as sort of like a step down piece to fill that 1/8 of an inch gap. What you do not want to do is just get a piece of flat bar and drill 2 holes in it to make your own custom bracket. I was hoping because my metal was thicker than the original bracket that would make up for the fact that I was losing some structural integrity with the fact it wasn't bent. But as soon as I went to crank on it to tighten everything down, this guy immediately started to rainbow and gave me a pretty aggressive curve. So this is not the solution, but you know, sometimes at RV Repair Woman, we try things so you don't have to. And this is one of them. For now, I'm just living with my custom bracket modification, but I'm definitely in the future just gonna notch this out and go back to the original brackets. And then the final modification I did that I have not seen anyone online talk about, especially for putting this type of air conditioner into an RV where that air box is going to be a little larger than what the air conditioner was designed for, is adding an insulating wall to separate the outgoing air from the incoming air. This was kind of hard to get on camera, but I'll draw you a picture. If you were to install this AC into like a Class B where you have a smaller air box, then the duct coming from the roof unit and the little duct coming from the faceplate could meet up. And that would keep the warm air coming in and the cool air coming out separate. But because my air box is longer, these 2 pieces of ducting aren't touching. And now my cool air and my warm air can mix. When this happens, you can end up with a situation called short cycling, where the air conditioner starts sucking in cool air, trying to cool it, and just turning itself into a block of ice. This doesn't happen instantaneously, but it is something we look out for, not just on 12-volt air conditioners, but on traditional 120-volt air conditioners on RVs, and even on an air conditioner you might have on your roof. If you've ever had your air conditioner freeze up, there was a good chance that it was caused by this short cycling issue. I just took the same insulating wall that came with my old air conditioner and just put it in the same place for this new air conditioner to help insulate and separate that incoming air from the outgoing air. The manufacturer may think this is overkill and not something you have to do. It just literally cost me nothing because I already had that same piece from uninstalling my old air conditioner, and this way I can sleep a little bit better at night. But you live your best life, you may not find this necessary. So that brings us to wiring. This may be a little tricky for you in a traditional RV, or it could be really straightforward. It really depends from RV to RV. You see, in order to run this new air conditioner off of 12 volts, you're gonna need some much beefier wiring than what was originally wired to your 120 AC. For people with a little bit of electrical knowledge out there, the volts are going down, so the amps are gonna go up in order to have the same power usage. And more amps means you need a thicker gauge wire. If that lost you at all, just know you have to use the thick wires that come attached to the air conditioner. So we're gonna need to find a way to route that cable from your roof to your batteries. Once you figured out that run, the rest is plug and play. You can plug the jumper cable directly to the battery. There's built-in fuses and built-in battery protection, or you can attach it to your Lynx connector if you've got a fancy solar system. And then your jumper wires connect to your air conditioner wires with just this super easy push connector. But how are we gonna make that run? Well, this really depends from RV to RV. If your RV already has solar, or it says that it is prepped for solar, that means that you have a hole in your roof somewhere to help you run wires from your roof down to your batteries. That's all that prepped for solar means. They drilled a hole in your roof. So your new wires can just follow the path that your current solar wiring is taking or is supposed to take, and you're good to go. Heads up, if your air conditioner is kind of far away from your battery bank, you may need to get some longer cables just to help you make that run. But other than that, pretty straightforward. Just so you know, OutEquipPro sends you about 12 feet of cable. So a pretty good amount, but if you're trying to get from one end of your RV to the next, you're probably gonna need a little more. If you aren't prepped for solar yet, you're probably just gonna have to drill a hole in your roof, which I know sounds super intimidating to a lot of people. Just so you know, you could hire a tech just to drill that hole for you, and then you can do the rest of the air conditioner install yourself if that's something you're interested in. But if you do want to try drilling that hole for yourself, I've got a visual aid to help. Okay, so I know that this is an Airstream and doesn't look like most RVs out there, but it'll work for now. If you're trying to drill this hole yourself, a lot of the times what techs will do is they'll drill it right next to one of the vents for either your black tank or your gray tank. This is because we know that that vent goes usually a straight shot from the top of your RV through the whole RV and down to the bottom. So we can usually snake down and along that vent pipe and then branch off wherever we need to get to things. Sometimes that involves going all the way through the whole RV and then snaking around along the bottom. Sometimes, especially in like fifth wheels, if you start pulling away some of the false walls, especially in that big pass-through compartment you have near the front, you can usually find one of the pipes for the vent for either your black or your gray tank, and that's a great place to pop out and then get to your batteries. This is all a little more in depth than we can get in this video, but that's the general idea of how you would route those wires from your roof down to your batteries. Okay, so now that we've installed this 12-volt air conditioner, let's compare it to my old air conditioner. Let's start with noise. My old AC was loud on startup. You can really hear the difference when I do this side-by-side comparison. You can also hear that the 12-volt air conditioner takes longer to start up and does this slow ramp up, which makes that initial noise less noticeable because it slowly comes in as opposed to one big jolt all at once. The reason that you're getting that slow ramp up at the start is because the OutEquipPro air conditioner comes equipped with a soft start. So if you don't know what that is, air conditioners tend to take a lot of energy to start up. So it's usually this big blip of energy and then significantly less to run. I usually describe this as like trying to push a car from a dead stop. You usually have to do like one big heave to get the car going, but then once it's running, it's usually pretty easy to push. Same goes for your air conditioner. So what you're hearing when traditional air conditioners turn on is that big hit of energy that it's taking to get that air conditioner going. You can install soft starts onto these 120-volt air conditioners to help even out that startup process. That's usually about a $200 to $500 upgrade and additional thing that you have to get installed onto your air conditioner, and it just comes on this OutEquipPro air conditioner. So that's pretty cool. Not only does that soft start help with the noise reduction, but it can also help with the longevity of the air conditioner because it's not getting this like abrupt startup every time you turn it on. It's much more gentle. And overall, while running, the 12-volt OutEquipPro air conditioner ran at about 5 decibels quieter than my old air conditioner, and that was with the vents open. My old air conditioner didn't have a dump vent, so the whooshing air noise would actually be farther away from where the microphone was placed and much closer on this 12-volt air conditioner. So pretty cool how quiet it was, despite the fact that it was closer to where the air came out. And both of these sound tests were done with the air conditioner on its highest fan setting. Cooling. Both of these air conditioners cooled approximately the same. They're both able to pump out air that was in the mid to high 60s, which was quite nice. With RV ACs, you're always looking for a delta T of about 20 degrees. So you want the warm intake air and the outtake air to be about a 20-degree difference, and both of these were right about at that. Airflow. I will say that the airflow on the OutEquipPro air conditioner was about 2 meters per second slower than my old air conditioner, and that was with both air conditioners on their highest fan setting. Some of this just comes down to what the air conditioner was designed for. My old air conditioner was designed for ducted use, so you just need to be pushing more air to get it through the ducts, whereas the 12-volt OutEquipPro air conditioner was designed to be ductless, so it's just dumping the air straight down, and so you just don't need as much airflow if you're just not having to go as far. This is also how they're able to keep noise down just a little bit. And I personally find that the high fan on a lot of traditional air conditioners, when you have that dump vent open, just sort of feels like a tornado. Like we just don't need it on high fan once you open up the dump vents. So something that had honestly a little bit of softer airflow was a total pro in my book, but definitely something you should know. And then finally, the biggest place where you're going to see a difference between your old air conditioner and this OutEquipPro air conditioner is energy usage. And I knew there was going to be a difference. I did not realize how big that difference was going to be. It was pretty amazing, guys. I don't have an inverter on my rig, so in order to run my old air conditioner, I had to be plugged in. And my old air conditioner, when running, would come in at right around 1300 watts. That number will fluctuate depending on how hot it is outside and how long the air conditioner has been running, but it was pretty typical for my air conditioner. And is pretty typical for these types of air conditioners in general. Usually when people ask, I usually estimate the wattage for these air conditioners to be anything between 1200 to 1600 watts. It usually depends on the BTU rating of the air conditioner, how hot it is outside, how old your air conditioner is, a whole bunch of little factors, but you're always looking at something well over 1000 watts. For the OutEquipPro, I couldn't use the cute meter that just gave me the energy usage in watts, so I had to measure the amps and then multiply that by what I knew the voltage was to get watts, which if that math is scaring you, just stick with me because the solution is super cool. With both the compressor and the fan running, the OutEquipPro air conditioner was only pulling 22.73 amps, which once I multiplied that by the 12.5 that the battery sits at, that came in at around 287.5 watts. Less than a quarter of what my old air conditioner was pulling. That is insane for an air conditioner, guys. Like, shockingly low. Now, like my old air conditioner, that number is definitely gonna fluctuate depending on how hot it is outside, how long the air conditioner has been running, a whole sort of factors. I know when the Cummins camper did a very similar test on this same air conditioner, he was getting a wattage draw closer to 420 watts, which again is still almost nothing when it comes to an air conditioner. Like, insanely low, guys. So what does this mean for you? We're just throwing a bunch of numbers out there. Well, the wattage directly correlates to how long you could run this air conditioner off of a battery bank. So if I was trying to boondock with this air conditioner, first of all, I actually could. I could not boondock with my old air conditioner because I don't have an inverter. But even if I did, I could run this OutEquipPro air conditioner 2 to 4 times longer than I could my old air conditioner off of the same battery bank. And that's before we even factor in not needing to use an inefficient inverter in that process. Insane, guys. Insane. And even if you're not a boondocker, you're a camp queen that always is plugged in, getting your air conditioner off of the AC side of things can mean you can run more things in your RV at the same time. Editing Emily here. I didn't do a great job of explaining this at the RV. If you have a 30 or a 50 amp rig, what that number is telling you is how many AC amps you can have running at the same time in that rig. And so because your air conditioner is usually an AC appliance, when it's running, it's taking up a good portion of that 30 or 50 amps that you can have running in your RV. So if we can take the air conditioner and get it off of the AC system and put it on the DC system, that means that you can just have more AC appliances running at the same time.
Hope that makes more sense.
I know people in 30 amp rigs, like myself, really struggle to run, let's say, the air conditioner and the microwave at the same time. If I'm running both of those at the same time, I'm pretty quickly going to be pulling more than 30 amps and start popping breakers. But if I have my OutEquipPro air conditioner on and I've got that wattage now on the DC side of things as opposed to the AC, that means I'm no longer using up any of those 30 amps for the air conditioner. And I've got much more room to be able to run things like my microwave or my hair dryer or my laptop all at the same time without being worried about popping breakers constantly. So what does this look like in the end? Who do I think this air conditioner is good for? If you're in a Class B or a van build, this air conditioner seems amazing to me. The energy usage is out of this world. Its energy usage is shockingly low for the fact that it still pumps out fantastically cold air. And even if you're in a traditional RV like myself and you've got a pretty significant solar setup and you'd like to be able to run your air conditioner longer on the same battery bank, definitely check out this air conditioner. It could genuinely be life-changing to how you RV. And who do I think maybe could still try this air conditioner, but maybe want to put a little more thought into it? If you're in a traditional RV and you're just hoping for an air conditioner that's going to be totally plug and play, works perfectly, and has all the bolts, this maybe isn't the air conditioner for you in a traditional RV. And if you're nervous about having to drill that hole in your roof or you aren't already prepped for solar, that is just something you're gonna have to think about before you purchase this air conditioner. But if you're willing to just get some additional hardware and you're comfortable doing that electrical run, even for people that aren't interested in boondocking, I do think the fact that you've gotten your air conditioner off of the AC side of things and have moved it to the DC and just increasing the number of things that you can run in your RV without popping breakers could also be pretty life-changing for a lot of RVers out there. If you're interested in this air conditioner, check out the link in the description and let me know down in the comments what sort of modifications you did to get it to work in your airbox. But if this air conditioner isn't for you and you're still trying to figure out if maybe you could get 2 air conditioners running in your 30 amp rig, check out this video. And in the meantime, this has been RV Repairwoman. You got this.